Hey guys, so here's sort of our first attempt at true online learning. What you can expect is for me to post short videos like this, very similar to what we would have done together in class. But because it's a video, you have the opportunity to pause it. You can go back and rewatch things. You're welcome to write down any notes that you think would be helpful, but because you can keep coming back to these videos, I'm not going to provide you actual note sheets to write on. Plus, I know a lot of you don't have access to a printer right now. The other thing I want to say is I don't have access to an actual smartboard right now. So please bear with my handwriting at times. It's going to look probably pretty childlike, let's say. But writing with your mouse is not nearly the same as writing on an actual smartboard. So we're going to do the best we can, okay? We're going to pick up where we left off in the last unit. And that means that we're talking about our similar shapes, specifically similar triangles. We're talking about things being proportional, and so setting up those proportions to find different measurements. And so that's where we sort of pick up today. It says if a line is parallel to one side of a triangle and intersects the other two sides. So first take a look at the picture. We have a triangle, we have a line inside of that triangle BD. It's parallel to the base CE. So when they are parallel, it separates the two sides into proportional lengths. So because BD and CE are parallel, I can set up the proportion AB over BC equals AD over DE. So look at your picture. What does that mean? Follow the sides down on the left and the right. AB over BC, AD over DE. So we're putting the two pieces on the left and the two pieces on the right into fractions, setting them equal as a proportion, and that will allow us to find any missing lengths that we need to. This is helping us replace having to draw and label two separate triangles as long as these segments here are parallel. So if we look at an example, the example asks us to find X and AD. So I do have my two parallel segments, and because I have my two parallel segments, I can go ahead and set up a proportion. So I'm just going to go down the left side and down the right side to set up that proportion. So going down the left side, I've got 6 over 4, and that's going to equal X minus 2. And then on the bottom, we've got 5. Okay. What we want to remember is that when we are in a proportion, we're going to cross multiply. And if cross multiplying is easier for you to say, put the 4, put parentheses X minus 2, and on the other side, I have 6 times 5, which I know is 30, then that's fine. Go ahead and put the parentheses. If you want to just say, okay, this is 4X minus 8, equals 30, and you have that right off the bat, that's fine as well. Okay, you don't have to use the parentheses unless that's helpful to you. At this point, now you can go about solving your equation. So we're going to add our 8 to both sides. So my 4X is now equal to 38. We're going to want to divide both sides by 4. You'll see I'm sort of switching between typing and writing just because I know the handwriting's a little sketchy at times. And so that's going to give me 9.5. Okay. It also asks us to find the length of AD. Remember, we always want to go back to those instructions. So AD was equal to X minus 2, so 9.5 minus 2. That's going to mean that AD is equal to 7.5. And we would want that as part of our answer as well. Okay. If we take a look at the next one is asking us to determine if BD is parallel to CE. So now instead of one of these segments having, say, the letter X on it, both pieces on both sides have values. I'm going to set up the same proportion I would. So if I work down the left side, I'm looking at a 14 over 6. And if we look at the right side, we're looking at 21/9. Okay. And because I don't have any x value to solve for, I'm still going to cross multiply because what I'm looking for here is, does this proportion work? That's going to tell me if these two lines were actually parallel. So when you cross multiply 14 times 9 and 6 times 21, on both sides here, you're going to get 126. Okay. Doesn't matter which one you do first or second, they're giving you the same value. Ultimately, that's what you want. If they give you the same value, remember that means, hey, this proportion works. It was successful. So what did I learn? I learned that BD is parallel to CE because the sides are split proportionally. If the two values after cross multiplying were not the same, I would say that BD is not parallel to CE because the sides are not split proportionally. That's really what you're looking for is, were they split into proportional pieces or were they not? Sometimes this parallel line in the middle is actually going to be considered a midsegment. Oops. There we go. So a midsegment is that parallel to one side of a triangle and it connects the midpoints of the other sides. So if we mark our picture for that, parallel, you know, I can put in sort of those triangle markings, right? And then think about what it means to be a midpoint. If C is the midpoint, remember that's going to make EC and CA the same. And if D is a midpoint, that means ED and DB are going to be the same. It doesn't make all four pieces the same because it's still possible that your left and right sides were different to begin with. So in addition to having these equal pieces now on the left and the right, the length of a midsegment is 1/2 the length of its parallel side. So if I were to set that up, let's say as a formula, the midsegment in this picture is CD. It's saying it is equal to 1/2 the side it's parallel to. And in this case, the side it's parallel to was AB. So that's what I'm going to use should they ask me to find the length of the midsegment. This midsegment is always 1/2 the side it's parallel to. So that's the relationship between them. So if we look at an example, it says to find X and Y if AB is a midsegment. So they're telling me point blank, AB in this picture is a midsegment. Well, we just said that the length of a midsegment is 1/2 the side that it's parallel to. So that means that if I want X, since X is on my midsegment, X has to be 1/2 of 24. Okay. And you could have just put 24/2. Either way, we should know that X is 12, right? And so that's our answer for X. What you should also know is that because it's a midsegment, remember it's going to give us midpoints that it's connecting. So if B here is our midpoint, remember that's going to make these two segments here congruent to each other or equal to each other. So I can say that 3y minus 9 is equal to 2y plus 6. Okay. And now it just becomes a matter of solving. So I can subtract, for example, 2y from both sides. That's going to give me a y minus 9 equals 6. And then I can plus 9 to both sides, and so my y is going to equal 15. So there's my work for y.